Find the cube root of -125 and show the roots on the complex plane. Now, if it's a real number equation, right? As you know, x to the power 3 is -125. X is the cube root of -125. And then we get -5. And that's it. That is for real number. Okay, but now we are talking about complex number. So complex number solution won't be just one. Okay. The solution you get, the cube root of -125 equals -5. That is only one of the root. Okay, the first root is -5. Okay, then what is the other root? Yeah. Now, -5. Let's look at -5. -5 equals 5 times -1. Okay, so 5 is, of course, the R. And then -1 is 6. What? Okay, think about this. Argon diagram. -1 is here. So if I go this way, it's pi. Okay, so -1, if I write in the polar form, it is the argument is pi. So 5 times -1 is 5 6 pi. This is Z1. Okay, now since it is to the power of 3, so there must be 3 roots. As we learned previously, a whole circle is 2 pi. 2y divided by 3, so it's 2 pi over 3, 2 over 3 pi. Okay, that means the other root should be 5 6 pi minus 2 pi over 3. Okay, that is 5 6 pi over 3. So, okay, if this is the first root, the other root should be pi over 3, and then the radius is also 1. Okay, now you may wonder, why cannot we plus? Yeah, we can. Let's see. Pi plus 2 pi over 3, then is 5 6 5 pi over 3. Okay, the problem is argument. Argument is always more than -pi and less than equal to pi. So obviously 5 pi over 3 is bigger than pi already. Since both the sine and the cosine has a period of 2 pi, so we just minus 2 pi. So that is the third root. But of course, you must double check, make sure they are 3 different roots. These are the 3 different roots. So how do we know? Okay, firstly, we know the radius. Modulus is 5. Okay, let's say we have a circle of 5. Okay, a circle of radius 5. Okay, so the first root, Z1, is 5 times -1. So this is Z1. Okay, the second one is Z2. Z2 has an argument of pi over 3. Okay, Z3, -pi over 3. Okay, so here are the 3 roots, Z1, Z2, Z3. And the angle between each roots is 2 pi over 3. That is 120 degrees. This is example 23. Okay, example 24. Solve the equation Z24 plus I equals 1. Okay, so this one, Z24 equals 1 minus I. Now, how do we find the first root? Okay, this one I have to remember. We firstly rewrite this as polar form. Okay, as you can see, so this is 1 plus I times -1. That means the real part is 1, the imaginary part is -1. So the radius will be x squared plus y squared root 2. Okay, now you need to determine the argument. Positive half, negative half I, fourth quadrant. Okay, so fourth quadrant, if I check the tangent value, y over x, tangent inverse, -1 is negative pi over 4. And where's negative pi over 4? In the fourth quadrant. So very good. So z24 is √2, c is negative pi over 4. If it's not in the fourth quadrant, now if it's the other quadrant, you need to adjust the value of the argument. Okay. Now continue. So z24 is √2, c is minus pi over 4. Okay. Now because due to the de Moivre theorem, if z is r c theta, then z24 should be r24 cis 4 theta. So the argument times 4, the modulus to the power 4. If that's the case, r24 is √2, that is 2 to the power of half. Then r will be the fourth root of 2 to the power of half, which is 2 to the power of half to the power of 1 over 4. So 2 to the power of 1 over 8. Okay, so z is 2 to the power of 1 over 8. As for the argument, 4 theta equal to minus pi over 4. So theta is minus pi over 16. Okay, so this is how we work out the first root. Okay. So the modulus is √2 to the power 4, take the fourth root. And then the argument is minus pi over 4 divided by 4. Okay, after we work out the first root, so there are 4 roots, 2 pi over 4. So it's pi over 2. So we just need to plus or minus a multiple of pi over 2. Z1 is 2 to 1 over 8. C is negative pi over 16. So Z2, okay, we try to add pi over 2. Yeah, so if you do this in a calculator-free session, you must get it same denominator. So minus pi plus 8 pi, right? So that's why the second root, 2 to 1 over 8, is 7 pi over 16. Okay, still within the pi, that's good. So Z3 is 7 pi over 16 plus another pi over 2, 2 to 1 over 8, this time is 15 pi over 16, still less than pi. Okay, so we have the first root, second root, third root. Okay, but if I plus another pi over 2, that would be definitely more than pi if I plus another pi over 2. So instead of plus pi over 2, we come back to the first root, and then we minus pi over 2. That's how we get the last one. Last one is minus 9 pi over 16. Okay, so this is how we get the 4 roots. And then if I need to show the roots, we can just show like how do we do like how we did in example 23. So example 24, the most important thing is how to find the first root. Okay, so the argument to the power of 1 over 4, get the fourth root. But the modulus to the fourth root, but the argument divided by 4. Okay, so remember this. Modulus to the fourth root, argument divided by